Hi everyone, welcome back to another video. So as you can see, we're at a different location than where I usually like to film because usually I like to film these videos outdoors in front of my garden. But today I decided to change it up. So it's currently nighttime. I usually like to film during the day, but I had to change the scenery up because I decided to make a different kind of video. So for today's video, I have decided to cover the seasons on Earth. So I'm sure you all know what seasons are, and please do not mind the background noises. My frogs are croaking right now. Um, but yes, anyways, I have decided to film in front of this disco ball that I have in my room. I have my sources of light are these two flashlights here at the bottom and my lamp on that side. But yeah, I chose to use this disco ball because I can use it to sort of model as the sun because um, our solar system follows a heliocentric model, or much like every other solar system in the universe. This basically is just a fancy way for saying that the planets revolve around the star in a solar system. So our sun is a huge star, and our planets, or the planets in the Milky Way galaxy, which is the name of our galaxy, the one we live in, um, the planets revolve or orbit, I should say, they orbit around the sun. So here on Earth, when our orbit is around the sun is completed in 1 year. This is called a revolution. So our year begins in January and ends in December, as you all know. That basically just marks the revolution or one revolution around the sun for Earth. But yes, I just want to cover a few um, background facts before we get started because they are essential to know about, um, so we can discuss seasons. So, yes, like I mentioned, the sun is in the center of our galaxy, so that's very important to know. Here I have the Earth. You can't really see it as well, but I have the Earth and then I have the moon sticking on with a toothpick. Just for look, I thought it looked really cool. Um, but of course, none of this is um, to the same distance. I forgot how to say it. Um, but yeah, none of this is what's the word? What's the phrase? Excuse me, sorry, I forgot what the phrase was. But yeah, these distances are obviously not the same as they are in space, um, because these celestial bodies are just huge things in the universe, like planets, stars, nebulas, all of that. So these celestial bodies are so huge. They're so huge that our brains can't even begin to comprehend just how big they are. Oh, it's okay. I just remembered. So none of this is to scale. There you go. This video is definitely not to scale because, for example, right here, the Earth, I I'm using the disco ball as my sun. So the Earth is definitely not this close to the sun. Um, the Earth is about 150 kilometers away from the sun. The moon is around um, 350, roughly. It's roughly around 350,000 kilometers away. And the Earth is around 15,000, probably not even, but it's around 15,000 kilometers wide. So exactly, none of this is to scale. Also, just a little quick uh, fun fact: I decided also to use this disco ball because, as you can see, the in the background, they look like stars in the universe, and that's just so cool because look, like they all look like stars. But yes, anyways, let's get started. I've been rambling on for quite a long time. But yes, so the Earth, we all think of the Earth looking like this, standing upright on its axis. Its axis is just an imaginary line from the north to the south. So we usually imagine the Earth standing upright on its axis like this, but the Earth is actually tilted more like this. It's not this exaggerated, but I um, I just sort of exaggerated it a bit to emphasize the difference that the tilt makes. So yes, we usually imagine the Earth to be upright like this, but it's actually tilted at a 23.5-degree angle. So this is if it were tilted 0 degrees, and this is if it were tilted 23.5 degrees, roughly. None of this is to scale, again. But yes, so the Earth is actually tilted. So that's one main reason as to why we have seasons. Um, I like this foam ball. I painted the Earth, this Earth. So I like this foam ball because it has a line right in the middle of it, which can be seen as its equator. So um, the equator on Earth is able to separate it into the northern hemisphere and southern hemisphere. So here, I live here in Los Angeles, which is part of the northern hemisphere. So I will be focusing on the northern hemisphere for this video, since both hemispheres witness different things, much like they see different stars than us, and they have different seasons than us. Not different seasons, but their times are different. But yes, so I will be focusing on the northern hemisphere specifically for this video. But yes, the Earth is at a tilt, and we also think that the Earth orbits in a perfect circle around the Sun. Well, most of us think that, I'm sure, that the Earth orbits around the Sun in a perfect circle. And this is actually not true. The Earth orbits in uh, like an elliptical, so like in the shape ellipse. An ellipse is much like a circle, but it's has a bit of a eccentricity. So what do I mean by eccentricity? By eccentricity, I basically just mean that it's a little bit wider than a circle. So as you can see, I'm gonna use this disco ball as an example. So this is a sphere. This disco ball is spherical in shape, but if it were elliptical, then this this disco ball would be more wide, like this. So right now it's like this. It would be more wide. So in an ellipse, there are two foci, or 2 points. So if this were an ellipse, it would have two foci. Um, that's plural. Singular is focus. So these are 2 points, which are the foci. Um, the more eccentric a celestial body is, or yes, like a celestial body, a circle, a sphere, anything, the more eccentric it is, the more wide it is at its diameter. So the more stretchy it goes. I hope you guys understand. Um, but yes, that's what an elliptic that's the path that the Earth follows around the sun, or that's the sun's apparent path, I should say. It's called the elliptical plane. So it's not a perfect circle, but it's definitely not far from being circular in shape. But yeah, just another little fun fact: the Earth is actually a bit eccentric. I think it's around 0.017% eccentric, which is like 1%. So pretty much really nothing. Very, very subtle. Um, but yeah. Um, anyways, yes, the Earth, the sun's apparent path is called the elliptical. So just the orbit that the Earth follows, like this. Um, so what makes this special is that the Earth is actually closer to the sun during a certain time period. So, contrary to popular belief, the for the northern hemisphere, the Earth is actually closer to the sun during winter time for us, which is very mind-boggling because you would expect it to be the opposite. You would expect the Earth to be farther away from the sun during winter since it gets so much colder. So why is this? The reason for this is because um, Let me start off with this. The northern hemisphere and southern hemisphere um, witness different times and seasons. So while the northern hemisphere is going through winter time, it's the opposite for the southern hemisphere. They're going through summertime. Um, so yes, let me show you guys this because it's a bit hard to visualize without having an actual visualization to witness. So yes, like I said, the Earth is tilted just like this, 23.5 degrees. So as you can see, the foam ball has the equator, which is that line right there going in the middle of the Earth. So the Earth is tilted like this. Um, the southern hemisphere is actually um, is getting more light from the sun than the northern hemisphere is. So as you can see, I drew the countries here. Oh, don't mind this. I'm using a T-shirt to hold the flashlights. So this would be um, cutting the Earth in half, just like this. So at all times, the Earth is illuminated. Well, half of the Earth is illuminated by the sun at all times, just like the moon. The the reason that it looks different though is because of our position. So at all times, one half of the Earth is getting illuminated by the sun, and the other half is dark, which is basically just nighttime and daytime. So let's say the sun is right here. So this half to the left of where I'm point of where I'm cutting it to the left, so this side is getting illuminated by the sun, while this half is not. So this would cause winter in the northern hemisphere and summer in the southern hemisphere. Because like I said, it's cut in half right here. So let me show you. So this is the sun, the disco ball. As you can see, the sun is illuminating the southern hemisphere more closely. Of course, we still get sun during winter time for us, but since the Earth is tilted, it's a lot more scattered and less direct for us in the northern hemisphere. So as you can see, the sun is very direct for the people in uh, Chile, for example, which is right here, which is close to here, because this is South America. My painting is kind of bad. I definitely didn't do it to scale either, but yes, this would roughly be where Chile is at. So yes, the people in Chile are seeing the sun more directly. The sun's rays are shining brighter on the people of Chile, while here in the northern hemisphere, it's not as direct. But since the Earth follows an elliptical orbit, it would be closer to the sun right here and farther from the sun over here. Do you see that? So, again, closer to the sun, farther from the sun. Do you see that change in distance? Yes. Okay. So, right here, for example, like I said, it would be summer for the people in Chile, which is in the southern hemisphere. And over here, it'd be summer for the people in the northern hemisphere because now it's our turn to get more directly illuminated by the sun. Can you see right here? So I can't do the rotation of the earth like this. I would need more arms for that. Um, but yes, the earth rotates every day. What it completes one rotation in about 24 hours. I say about 24 hours because in reference to the sun, the Earth completes a full rotation in 24 hours, but in reference to the stars, it completes it in around 23 hours and 56 minutes. Um, this is called the sidereal day, which is in reference to the stars. But we follow a solar day, which is 24 hours for us. So, again, while the Earth is orbiting around the Sun, which takes 1 year, it is also completing rotations on its axis, which is completed in 1 day for us. So it's moving something like this. Like this. You guys see that? Moving something like that. I can't really do it as well with this model because, well, I'm using basically a chopstick to hold the earth. Um, but yes, the two main reasons for seasons on Earth is the tilt on its as is the axial tilt of Earth and the elliptical orbit around the sun of Earth. Now, what if the Earth were standing upright, like just like this? We would not have seasons. Do you see that? So, like I said earlier, the sun is more direct in the southern hemisphere here, which is summer for the people in Chile, and the sun is more direct on us here, which is summer for us here in Los Angeles, for example, which is in the northern hemisphere. Now, what about when it's over here? So these are the two ends, which is summer in the southern hemisphere and winter in the northern, no, excuse me, and summer in the northern hemisphere over here. What about these 2 points right here? So this is actually autumn and spring. So for us here in the northern hemisphere, this would be spring and this would be autumn because this is summer and this is winter for us. So um, these seasons are actually marked by different dates. So, for example, the start of winter for us is the winter solstice. Now, the solstice, there are two solstices, the winter solstice and the summer solstice. This basically just means that days are either longer, which is the summer solstice, or days are shorter, which is the winter solstice. So the summer solstice is the longest day on Earth. By this, I basically just mean that the sun is shining on the Earth for more than 12 hours a day. So if the sun shines 12 hours a day exactly, and is the Earth is dark for 12 hours exactly, which is equal 24 hours, 12 and 12, that would be called an equinox. So there are actually two equinoxes. There is a vernal equinox, which is the start of spring, and an autumnal equinox, which is the start of fall or autumn. So, yes, the equinox basically just means equal times of um, day and night, and the solstice is kind of the opposite. It means either more day or more night. So, yes, the solstices and equinoxes mark the beginning of um, the seasons here on Earth. That's how we're able to get exact dates of the start of seasons. So, the reason I made this video is because, well, spring is coming and spring is my favorite season. So I kind of just wanted to cover this topic just in case anybody out there was curious. So let me sum everything up because I have gone on a long time. Um, so basically, the earth is not floating upright like this. It's more at a tilt. This tilt is around 23.5 degrees at a 23.5 degree angle. And while the earth is tilted, it rotates on its axis. Um, it rotates on its axis in about 24 hours while it's completing one revolution or orbiting around the sun, like this. So the earth really moves a lot. Um, the earth actually, at the equator, the earth actually moves over 1,500 kilometers. Um, it's so, the earth is spinning very fast. But again, like I said, um, the earth is huge, and just imagine how much bigger the sun is than the earth. Like I said earlier, it's a lot harder for us to imagine since we can't really comprehend all those those great distances. Um, but yes, um, to review, the two main reasons the Earth has seasons is because of its axial tilt and its elliptical orbit around the sun. Well, I hope you guys enjoyed this video. I hope you learned something. I do apologize if I was a bit confusing, but I really hope you guys were able to understand. If not, I encourage you to do your own research in case you are curious, just to learn exactly how the Earth behaves in our solar system. But yes, thank you guys for watching. I hope you have a good night.